Good everyone, my name is Graphics. Today we want to solve the problem that is displayed on our screen, and that is on EEC, where we are told to find the equivalent resistance. The equivalent resistance is like saying the total resistance in the circuit. Now, if you look at A is a terminal, C is also a terminal, right? When I say a terminal, I mean that a point at which current can flow into the circuit where you connect to your source, right? Now, B is a node where two or more currents meet. Now, to give you a better understanding of this circuit, we'll start calculating from the back. Like this is my arrow. We'll start calculating from where? From the back. Now, if you look at this symbol that you're looking at, it is used to represent a resistor, right? And we know a resistor is a passive element. You can click on the link at the top right corner of the screen to know more about what an element is. Now, if current flows through A, as in through the terminals, let's say starting from A, right? Let's call it I total. It will get to point B, right? When you get to point B, it will split. When it split, let's now say I1 will go through this direction and I2 will go through this direction. We're assuming, right? Now, when the I2 move further and get to this point, let's call it point E, right? It further splits. Let's say I3 will go in this direction and I4 will go in the opposite direction. Now, this is what we'll be having. Now, this will guide you on how you know which of the resistor is in series and which of the resistors is in parallel. Now, let's start from the back. Because I1 is flowing through 2 and 5, you see, the resistance of these resistors are 2 and 5. So because the same current is flowing through 2 and 5, we say they are in series. And when two resistors are in series, you are going to sum them together. So when you sum 2 and 5, you are going to be having 7, right? So I will bring this back. You can redraw again. When you redraw, you're going to be having 7. Just know that the 5 and 2 are now 1. Now we'll still continue. If you look at this circuit again, we still have our I1 still there, our I2, I3, and I4 there. Now let's come to the 3 and 6 ohm. I mean this 3 and this 6 ohm. What do you notice? The same current, different current is flowing through them. I1 is flowing through 6. I3 is flowing through 3. Because of that, we say both of them are in parallel. There's a split at point E. So making 3 ohms and 6 ohm resistor in parallel. And when two resistors are in parallel, you are going to multiply both of them and divide it by the addition of both of them. So we'll be having 3 times 6 all over 3 plus 6, and this will give us 18 over 9, and this will give us 2 ohms. So it meaning that 3 and 6 are now 1, we're having 2 ohm. So I'll now replace it here. You can see, so you redraw and you have this. Now if you look at the same I2 is remaining here, that is still flowing on this line here. So I2 will go into 4 and will go into 2. Because of that sole reason, you say both of them are in series because they are in line, is on a straight line, right? So we'll say the 4 plus the 2 will give us 6 because the same current are flowing through them. So my resistance here will now be 6. So you can redraw again. Now, what do you notice? We're still starting from the back. Don't forget that. We have 7 and 6. You realize that I1 is flowing through 7 and I2 is flowing into 6, making both of them in parallel because two different currents are flowing through the two resistors, right? So we'll now multiply both of them and divide by the addition of both of them. So we're having 7 times 6 all over 7 plus 6. This will give us 42 over 13. Now 42 over 13 will now give us 3.23, right? So if I redraw, my 8 is still intact. The important thing is that what? My I total that is flowing from the beginning, right, is flowing through 8. The same I total is flowing through 3.23. Because of that, we're going to add both of them. Now, what do you notice? This we have already brought all the resistors into this final 2, right? So we'll now see that our arrow equivalent will now be the addition of the both of them. Why am I using arrow equivalent or arrow total? Because this is the final part, right? No any other resistor again. So my arrow equivalent will now be 8 plus 3.23, and this will give us 11.23 ohms. So this is our equivalent resistance of this circuit. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.